All right. So this is page 6-9, okay? Not 6-7. Okay. You guys didn't like my label your axes joke? I'm going to make fun of your jokes too. All right. Please tell your neighbor if you can remember the name of the red group. Those are our alkali metals, yes. See if you can tell your neighbor the name of group 2. Alkaline earth metals.
What are these?
Then we have, do you want to know why they're called alkali?
Yeah.
Because when you throw that metal into water, it produces a solution which is basic, which is the opposite of acidic, okay? It is a basic solution, and the other word for base is alkali. Okay, so that's why they're called alkali, is because they produce a basic solution. And in grade 10, you'll spend a fair bit of time talking about acids and bases and their properties. Okay, what do we call all the ones in the middle, the yellow ones?
Transition.
Those are our transition metals. And then finally, we have group 17, the blue one. Those are the halogens. And then we have group 18, the noble gases. So you already know 1, 2, 3, 4, 5 marks of your quiz on Monday. Okay, and now we're going to make sure that we know these other 2 groups here. And I don't know if you managed to figure them out on your own. If you did, that's fantastic. If you didn't, I'm going to show you how to figure it out really easily. These 2 groups that are below the periodic table, let's go to, actually, make sure you've got your periodic table out, your green periodic table. If you don't have one, let me know. Because if we look on our periodic table, the very first element in that row below, the row below, is lanthanum. Lanthanum. And that means that that whole row that starts with lanthanum, those are called the lanthanides. Lanthanides. Now, our other group starts with actin. 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 And those are called the actinides. Okay? So, you don't have to work too hard. They're kind of funny names, but as long as you remember that on the end goes an ides, and then the first part of the name is the first part of the element name that starts that row, then it's not too difficult to remember. I used to make this an enriched thing, but then I was like, I feel like almost everybody in the world should be able to do that, right? You can look at it and just kind of get it from there, and just put ides on the end. Okay. So these are, here are lanthanides. And these are our actinides. And now moving on to page 70. Oh, no, that wasn't page 70. This is page 70. Here we go. These ones, it's really hard to like label the other ones and label these ones because, and especially these ones that are called the main group elements. And this is the one that most people get wrong if they're going to get something wrong because they forget about it. They forget about the main group elements. Don't forget me. Remember. And if you want, you can get yourself a highlighter. They're on top of the broken glass bin, okay? There's no broken glass on top of the bin, so it's okay. The main group elements are all ones in groups 1 and 2. And they're all the ones, so it's group 1 and 2. And then everything 13, 14, 15, 16, 17, 18, all of those are also main group elements. That's why it's a little tricky, because they're split in half. Who's in between the main group elements? Transition metals. So we have main group elements. We have main group elements. And if you take chemistry at university, probably your first year chemistry course will focus more on the main group elements than it will on the transition metals. You will get some mention of the transition metals, but you really get deep into those in like second year. Okay, so those are a little bit, you get a brief introduction, but you don't get into the depths of them till second year. And then down below, I don't know if you need to call these the inner transition metals. I think lanthanides and actinides would be sufficient. So I'm just going to write that, lanthanides and actinides. So which one is easy to forget? Main group elements. Remember those ones. Groups 1 and 2. And then what are the rest of them? Transition metals. And then groups 13 through 18 are the rest of the main group elements. All right. I'll let you do this little bit later, okay? If you get bored with listening to me, you can work on it right now, but I'm going to go ahead and we're going to go to page 71. There's not much new on page 71, okay? I believe, am I correct that it all looks the same on page 71, or do you have different colors, like different shades of gray? Slightly? I still need to work on it. I don't know. I need to go in here and definitely make my transition metals look different than my, what are the other ones? Main group elements. Okay. Now, the alkali metals, we didn't talk about this before, but one of the things in group 1 is not an alkali metal. Hydrogen is not an alkali metal. So let's put that in here. Hydrogen is not an alkali metal. Even more than that, if we were to draw our staircase, do you remember the staircase? Do you remember where the staircase starts? Staircase starts at this little corner here, and we're going to draw it right now. So go ahead and draw the staircase, goes down and across and down and across. If we ignore the metalloids, and if you're like, what are the metalloids? If you look up on that periodic table there, the metalloids are purple. Okay. If we ignore the metalloids, what kind of elements do we have to the right of the staircase? To the right of the staircase, we have noble gases, we have halogens, but the entire set of elements, like all the ones over here, those are all non-metals. That must mean that to the left of the staircase are all metals. And we can worry about the metalloids later, okay? So left of the staircase, so right of the staircase, non-metals, left of the staircase, metals. But we have one exception, one little weird element that does not behave. Aluminum. Aluminum is another element that doesn't behave. It doesn't behave in that it should fall into the metalloids category, but it's actually a metal. We have another one though, that's even a worse misbehavior than aluminum. That would be, I heard it. Hydrogen, yes. Hydrogen is not a, it is a non-metal. So even though it's to the left of the staircase, it is a non-metal. So it's bizarre. It's its own little group. Hydrogen does its own little thing, and we'll find out why it's kind of off by itself doing its own little thing when we look at its Bohr model and how it bonds, sticks together with other atoms. Okay, so we've got our main group elements, which are, here they're green. We have the transition metals, which are in the middle. The lanthanides and actinides at the bottom. What do we call the vertical columns? Tell your partner, what are those called when they go up and down? The up and down things are called columns, but in the periodic table we call them groups.
Wait, are the lanthanides and actinides also part of these groups?
They are actually, no, they are their own little groups, okay? And they actually, let me just find. That is 2.3E, page 76, 2.3E. This is what the periodic table should actually really look like.
Oh, is that why there's like a line?
That's why there's a line going from here, and then it goes down, and it's like, oh, these guys end up getting chopped out. So we actually chop out this little section, and we move it down below. And do you know why we do that? Because it fits better on a piece of 8.5 by 11 paper. Otherwise, you would have to have a big, long piece of paper every time you had a periodic table. And they get used very seldom. They are, most of them, actually, I think all of them are radioactive. So they tend to break down into simpler elements over time. So you're never going to be working with them in high school. I never worked with them at university. Did I? No, none of those ones. No. I did work with radioactivity, but it was like phosphorus. It was a radioactive isotope of phosphorus.
How is sulfur spelled? Because I keep saying it's spelled.
Sulfur is spelled, okay, here, yeah. Sulfur is weird. Sulfur can be spelled with an F, or it can be spelled with a PH. The official version is an F. However, all the resources for BC for all of my career have said PH for sulfur. So I have gone through all of my resources and made them all consistent. So they all say pH. However, if there is a sulfur with an F, that is actually more correct. So if you wish to use an F for sulfur instead of a pH, you go right ahead. Okay? I think the pH was more of a British thing, and the F was more of a an American thing. So the Americans won that one. But do you know what the official name for aluminum is? It's actually not aluminum. It is. Anyone from abroad here? Because I think North America is the only place that calls it. Not even all of North America. Mexico doesn't call it aluminum either. Aluminium. So the Brits won on that one. The Brits and the rest of the world, just not America. Yeah.
Aluminium.
So if you want to put that extra I in aluminum, you are welcome to do so. It is correct. Aluminium. Yes.
Now that I think about it, that's what my mom said.
Yep. Like I said, the only places that use aluminum are Canada and the US, I think. Yeah. All right. Where did I get to? Right. Back here. Okay. So columns are called groups. What do we call those things that go side to side? Those are called periods. Okay, so vertical columns are called groups. Horizontal rows are called periods. Periods are always referred to by their number. So you could say row 2 is called period 2. Row 3 is called period 3. Alrighty. And you must memorize group 1, 2, 17, and 18, the alkali metals, the alkaline earth metals, the halogens, and the noble gases. All right. Could you please, just by way of a little review, see you guys later. By way of a little review, could you please draw the staircase once again and then shade in the non-metals? So this is on page 72.
The non-metal?
You're going to shade the non-metals. We can ignore the metalloids if you'd like.
So are they like part of the non-metal?
They're kind of part of the metal. You know what? If we're just using the staircase, we're going to say everything to the right of the staircase is non-metals. We're going to say everything to the left of the staircase is metals. We'll worry about metalloids when we're worrying about metalloids, which we're not right now. Is everyone happy with what I have shaded? Uh-oh. Samaya? Yeah, we need hydrogen shaded as well. Okay, hydrogen must also be shaded. So if I were to ask you to shade the metals, the metals are going to be like this. Okay, so I'm going to go like la 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 la. What about the lanthanides and actinides? Are those metals or non-metals? Are they to the left of the staircase or are they to the right of the staircase?
No.
They are to the left of the staircase. So the lanthanides and actinides are metals. There we go. Now, you guys have done some observing of some elements in the last few days, and I would like you to tell your partner some properties. And actually, before I get you to describe the properties, I would like you to tell your partner what the word property means. What is a property?
The characteristic. Yeah.
A property is a characteristic. Could you please tell your partner some properties of metals? Something that all the metals you looked at had in common.
Solid.
So remember, we looked at their color, we looked at their state at room temperature, we looked at shiny or dull, and we looked at color, state, room temperature, shiny or dull, and magnetic. What do you guys think? What is one property of metals? Let's hear from someone I haven't heard yet from today. Yes. They're all solid at room temperature. There is one exception. Does anyone know what it is? Mercury. What is the symbol for Mercury? HG. Oh, you haven't. Sorry. Never mind. I'll collect it later. Mercury is Hg. What state is Mercury? It is a liquid at room temperature. It is the only liquid metal at room temperature. There's another one that gets awfully close. Does anyone know what it is? No, it will actually melt in your hand. Yeah? Gallium. I've actually had, like, in my hand, a sample of gallium. The only thing is it makes, like, because it reacts with some of the water on your skin, it leaves a black mark behind and it makes it kind of black. So it's better if you put it in, like, some plastic wrap and then you hold it in your hand and it melts, which is kind of cool because you're like melting a metal. Ooh. Most metals, you have to go to like 800 degrees, but not that one. All right, what else have we noticed about metals? We got their state at room temperature. Are they shiny or are they dull? They are shiny. Shiny, not shinny. And lots of people think that all metals are magnetic. Are all metals magnetic? No. In fact, most of them are not. I was looking around because it's actually iron, cobalt, and nickel. I was hoping we might have some nickel in the back room, but I could not find any nickel. I'm going to see if I can get a supply for next year. But yeah, nickel is another one. But really, most of them are not magnetic. And if you ever get to study about magnetism, it's really quite exciting why they do that. It has to do with their electrons and how they spin, which is like, whew, cool. But anyway, so those are two properties of metals that you should be able to tell just because you're familiar with metals. You can be like, oh, look, here's a clip. It's made out of metal, and it is a solid at room temperature, and it is shiny, other than the part that is painted, because that's yellow, that's paint, right? So you don't have to think too hard. Now, there are a few other things about metals that we need to know. Do you guys know what density is? See if you can describe density to your neighbor.
It's like
You might have learned it last year.
it's like the amount of particles you can fit in a small. But because like you could have a really small like thing, but it might have a lot of particles, so it's heavier together. Yeah, it could be passed together. But you could have like a big balloon, but because there's not a lot of particles in it, it's like light, like Costco. Exactly, like Costco. Exactly. Yeah. I want to go to Costco someday.
Okay, would anyone like to describe density? Anyone who hasn't talked to me yet? You guys are too shy? Okay, so if I said I have this ruler. Okay, it hit me on the head, did not hurt me. Okay. What didn't mean it to hit me on the head? That was kind of, just me being my usual clumsy self. Is this dense or not dense? Does it have a high density or a low density?
High density.
If it had a high density, I would not want to do this, because if it had a high density, this would hurt because it would have a lot more mass for its volume, for its size. Okay? So imagine that I had, what's a good thing? Imagine that I had like a fire poker, like one of those things that's made of iron. Would I want to be doing that to my head with a fire poker? No, that would be a bad idea. It's about the same size, but I can do this and I don't get hurt because it's light for its size. But if I do it with a fire poker, I'm going to damage myself, and that would be awful. Okay, so yeah. Density is the amount of mass in a given size of matter. The amount of mass in a given volume. So if something is high density, it is heavy for its size. What can we say about something that is low density?
Light.
It's light for its size, absolutely, yes. What do you think about metals? Are metals generally, not every single metal, but are most metals high density or low density? High density. Okay, so if you imagine trying to pick up, how people have those weighted vests? Have you ever seen them?
Yeah.
They've got these weighted vests, and they put it doesn't even have to be a weighted vest. What do they make weights out of? They usually make them out of metal. They usually make them out of iron, right? You're pumping iron. And why is that? Because it gives you a lot of mass for the size. They wouldn't make them out of plastic. Plastic is mostly made of nonmetals. It's made of carbon, hydrogen, and oxygen. And if you made your weights out of plastic, you'd be like, right? So
or maybe just use really big weights.
you would have to use gigantic weights. So the density of metals, so these are all our metals here. Metals are shiny, metals are solid, except mercury, which is a liquid. Their density is high. They feel heavy for their size. And then there's a couple of words that you are expected to know the meaning of, okay? One of those words is malleable. Malleable. And if you're like, how do I spell that? Can you spell the word mall? Like I'm going to the mall. So you write mall, and then you write E, and then you write able. Mall, E, able, except for it's malleable. Let's try saying that. Okay, I'm going to count down from 3 to 1. We're all going to say the word malleable. 5, 4, 3, 2. Malleable. 5, 4, 3, 2. Malleable. 5, 4, 3, 2. Malleable. And how do we spell it? It starts with the word mall. It ends with the word able. And what's in between? E. Okay, excellent. So malleable means that if you hit this thing with a hammer, it's not going to break. It will just deform. Have you ever, like, you know how blacksmiths, like they take some metal and they make it into a horseshoe or they make it into a sword? How do they do that? They do it by hammering it because the metal is malleable. If it were to break, that wouldn't make a very good sword, would it? It would just be like, oh, the blacksmith hits it to make it into its shape and it goes like glass. That's useless. Bye-bye sword. So, and back when I was a kid, we did not know this was a really bad thing to do because it's actually very bad for the trains. But what we would do is we would leave a penny. Do you guys know what pennies are?
Yeah.
I know they're hardly around anymore, but you may see them in science class from time to time. We would take a penny and we would put it on the train track, and then the train would go over it and it would get squished flat. So a whole train could go over this penny and it would just get squished. It would not break. But it's actually really bad for the train. But we didn't know that because we were young and stupid because, you know, we were like 8 years old. Well, it's just not good for the track and for the train. It just means there's going to be a little bit of wear and tear on the wheels and on the track itself. So it just means they'll like need repair sooner. So had we known, you know, had our parents been, probably still would have done it because we were young and stupid, you know, but right, I know. Anyway, so they're going to deform or dent when they are hammered rather than breaking. So those are our metals. There is another one, and we'll talk about brittle in a minute, but right now we're talking about metals. Metals are malleable. There's another one called ductile. DuckTales. Sorry, do you guys even know what DuckTales are? No, there used to be a cartoon called DuckTales.
Oh, I know DuckTales.
Yeah. Yeah, that kind of thing. Okay. So ductile means that you can take it and if you pull it really, really hard, it will actually stretch into a wire. Yes? Where do you find wires in your house? Inside your walls, yes? Sometimes inside the ceiling. What else could you find inside your walls and your ceiling? Yes, you might find rats, but you also might find ducts. Yes? Like the ducts that bring like heat places and things like that. So if you have trouble remembering what ductile means, it might help you to think, what's in my walls? Wires and ducts. If that does not help, I had a student one year in Chemistry 11 who said, you know, he was asked to define ductile, and he said, we'll stretch into wires like a duck. It's stretchy like a duck, which makes absolutely no sense. But it was so absurd that he remembered it. So if you can imagine that you have a duck and you take this, you know, like one of those rubber chickens or whatever, but make it a duck and then make it stretchy. And you can imagine you've got this rubber chicken or rubber duck and you're stretching it. I don't know. At any rate, you do need to know that word. It is a vocab word. So able to be pulled into a wire. What are your pots and pans made of at home? They're made out of metal. Why is that? Because they are very good at conducting heat. Back in the 1980s, there was this whole like trend of having glass pots and pans, which was a bad idea because they were made of nonmetals, and nonmetals are poor conductors of heat. So it would take so long for the heat to get from the heating element up into, you know, the water in the pot or whatever. It was crazy. Like, it was a really dumb idea, but I guess like nobody knew better, so they would just buy them. This shows you how smart the consumer population is. You know how McDonald's has a quarter pounder? Okay. Well, Burger King advertised that they were going to have a burger that had a third of a pound. And then a whole bunch of people didn't want to buy it because they're like, why would I want to buy a hamburger that has less meat? And if you don't get it, I want you to go home and think about that. Okay. At any rate, conduction of heat for metals is good. Remember pots and pans. What else are metals good at conducting? Electricity. So they're good conductors of electricity. That's why your wires are made of metal. Okay. And once you know one set of these, the other set is, most of them are kind of like opposites, but not all of them, okay? So let's go to our periodic table. Take a look at our nonmetals. Carbon. You guys saw some carbon. Was it a solid, liquid, or gas? What's in your pencil? Lead, except for, is it really lead? No, it's actually carbon. It's a kind of carbon called graphite. Okay? Is carbon solid, liquid, or gas? Solid. You saw sulfur the other day. What color was sulfur? Yellow. Was sulfur solid, liquid, or gas? It was solid. So we had a solid. We've got sulfur, which is a solid. I'll let you know that right now that phosphorus is another solid. Selenium is a solid. Iodine is a solid. Those are all solids. You don't need to know those ones, okay? You just need to know that there's a bunch of solids. What about the noble gases? What are they? This is not a trick question. What state are noble gases? They are gases, shockingly. Gases, okay? Gases. How about nitrogen and oxygen? Nitrogen and oxygen are gas. Do you guys know about fluorine and chlorine? We're going to take a look at those ones tomorrow, but I'll just give you a little preview. Fluorine and chlorine are gases. So nonmetals are a mixture of solids and gases, with one exception. Who's our little exception there? Bromine. Do you remember seeing bromine on that video? It was that dark, sort of orangey brown liquid, yes? So that is our exception for the nonmetals. All nonmetals are either solid or gas, except for bromine, which is a liquid. So you should know that mercury is a liquid and bromine is a liquid, but those are the two exceptions to everything else. Okay? Here we go. In general, nonmetals are not shiny, they are dull. Nonmetals are solids and gases, except for one, which is bromine, which is a liquid. Are nonmetals generally dense, high density, or low density? Wood is made of nonmetals. Low density or high density? Low density. Now, the opposite of malleable is brittle. Anyone heard the word brittle before? Okay, if you have not heard the word brittle, it almost sounds like it is. Brittle, brittle. You can imagine that if you hit some glass, it would go, right? Brittle. Brittle means breakable, essentially. If you hammer it, it's going to break or shatter. So your nonmetals are generally brittle. It's just like, think about the lead of your pencil. What happens if you hit it too hard? It breaks. Okay, especially if you've got, the nice 0.5 lead, right? Yeah. Okay, so it is they are brittle, which means they break or shatter when they are hammered. There is no word for not being ductile. We just say they are non-ductile or not ductile. You cannot take, if you were to take the lead of a pencil, do I have any here? I do. Here's a pencil lead. If I pull on it, I could pull on it forever. Would it stretch? No. If I pulled on it super hard, it might break, but quite frankly, my fingers are too slippery and I can't get it to do anything. It's actually got a lot of strength that way. It's easy to break this way, but it's hard to break by pulling. But it does not stretch, so it is non-ductile. Unlike a duck. Are nonmetals good conductors? No, they're poor. So these are the ones where it's all opposite. If you know that a metal is a good conductor, then you know that a metal is a non-metal is a conductor. Are you guys playing on your phones back there? Are you guys playing on your phones? Are your phones in your bags or are they up in the cell hotel? Please go put them up in the cell hotel. Thank you. All right. And so let's see. You guys are responsible for memorizing this table. Okay? Because it's not difficult. Mem or eyes?
Can we just memorize
Okay, so you're going to memorize it. But here's the thing. If you want the regular quiz, this column on the left-hand side will be given to you. It will say appearance, state at room temperature, density, and then it won't say malleable or brittle. It'll say what happens when you hit it with a hammer and what's the word. Okay? Ductile or non-ductile, it won't say that. It'll say what happens when you stretch it and what's the word. So you would have to say malleable, it will deform when hit by a hammer. Ductile, it will stretch when you pull it. Conduction of heat, conduction of electricity, those ones will be given to you. If you want to do the enriched version, you will get a blank first column and you can fill in the descriptors yourself and then say what happens with them. Does that make sense? And when would that quiz be? Monday. So what we're going to do is, for the rest of class, but we can go out for a little walk before we do this, We can do number 2 and 3. And then we're going to skip metalloids because I've been talking way too much today. We're going to do 2 and 3, and we're going to do 4. So we're going to do 2, 3, 4, 8 to 12. 2, 3, 4, and 8 to 12. And that's on pages 72 to 75. But before we do that, we're going to go out for a walk because it's the last day of sunshine. So let's go.